All right, so what's next? In the past videos, we've proven, right, mathematically that merge sort is n log n. So this is, great news for us, right? We know how fast it is, and we proved it. A question though, right, and this goes back to our little intermission on matrix multiplication, is can we do better, right? Is it possible to write a sorting algorithm that sorts in quicker than n log n time? The answer to that is actually no. N log n is the best, the very best you could ever do, right? Merge sort, quick sort, things are n log n time. We cannot beat those algorithms for the general case of sorting. Now, what we want to do, and we'll spend our next section on this, is to actually prove this. So we're going to prove what is called the sorting lower bound, which is to say this is the minimum amount of work that any algorithm needs to do. Now, for yourself, maybe think about this a little bit and how hard this could be, because it's a little bit of a strong claim, right, to say that there is no better algorithm. Because then you have to make a proof that's on the problem itself. You need to say this problem requires so much work. Any algorithm, right, in any world, right, on any computer, under any operating, under anything, requires n log n time, right? That's a very strong claim to make, and the only way to make it is by looking at the problem itself and saying that problem is so complicated that it requires at least this much work, okay? It's a little bit complicated to do, because when we want a proof, right, a lower bound proof, and this is why people typically don't do them, right? They're very hard to do. Your proof needs to somehow be about the problem itself. So for us, right, we're used to all these assumptions, right? We have assumptions like, oh, I'm programming in Java, I'm programming on load store architecture, I'm programming in this world. Your proofs, right, need to encompass more than that, right? They need to be the end all, right? We just say that for anything that could ever be, right? So in all the billions of years to come, right, no one will ever make a sorting algorithm that's faster than n log n, right? That's essentially what we're trying to prove. That takes a little bit of work. So maybe think about that. I for one, think it's kind of a cool concept to look at. We are going to spend some time, right? We are going to do it, right? We are going to do it for sorting. We're going to prove that there is no better algorithm. So think about it for a little bit. I'll see you guys in the next set.